want to take a stab at it? Each type of function that we're going to learn about, the first thing I've been doing is I've been teaching you about some of the, like unique properties, idiosyncrasies that belong to square roots and fractions and eventually logs and exponents. Okay, I mean basic stuff like why are there asymptotes? Why does this half of the graph not exist? Right? Why is there a hole in the graph? And hopefully you kind of get the theory behind that. Okay, so part A. Part B, I need you guys to be able to, know what the graphs look like. Okay, square root graphs, you should be able to do more or less most of those without a calculator. Rational graphs, you should be able to know at least some generic looks at what they're going to be like. Okay. Sometimes you'll need your graphing calculator. Okay. We're doing part C now, which is you still need to be able to do the algebra behind them and solve. The good news is that because I knew in grade 11 that I was going to teach you guys in grade 12, I really focused on this last year. So I'm hoping that last year's pain is now this year you're like, okay, I recall this so that we don't have to spend 2 weeks on this stuff. We just have to do a refresher course. That's my hope. So before I do this example here, I should point out that individually, we should be able to consider what these look like as a graph. Right? Like if you were to take y1 and make it equal to the x squared plus 2 over the x minus 3, and take y2 and make it equal to the x minus 6, you could solve things that way, right? Like x minus 6 would be a linear line, like say roughly like that. And then if I were to graph the x plus 2 over x minus 3, without a calculator, tell me something about that graph. Like what's a unique property about this graph right here? Yeah, there'd be an asymptote at 3, so somewhere over here there's an asymptote. And then I don't know what the rest of the graph looks like, but there's a good chance that it has kind of the whoosh, whoosh. Ooh, that was really bad. Slipped there, right? So I mean, right off the bat, I'm kind of expecting that, there could be 2 answers, right? That would be logical if I were to have an answer over here and an answer over here. Right? So now that we have a better idea of what this looks like visually from a graph perspective, hopefully that helps us understand why we get the answers algebraically we do. Okay, let's do this example and then maybe 1, 2 more, and then we can reassess if we need to do more. So, Pirates of the Caribbean, Johnny Depp, wait for the opportune moment to fire that bullet. The bullet in this example, in this analogy, is you need to cross multiply. Okay, the opportune moment is where you have a fraction over a fraction. And it doesn't look like you have fraction over fraction, but you do. It's an over 1, right? So cross multiplying mathematically just means multiply the x minus 3 to the top and the 1 to the top. Stop me if I go too fast, okay? So left-hand side is still x plus 2. Right-hand side is x squared minus 9x plus 18. No. Yeah, 18. I can do math. Okay, pause for a second here. This now looks quadratic. Does that make logical sense that we can end up with a quadratic? Didn't I just show you with a brief thought of a picture that I could see why this would cross in 2 locations? Right? So if we're going to get 2 answers, we better solve it using a quadratic method. So bring the x to the other side, bring the 2 to the other side. Gives you x squared minus 10x, what is that, plus 16? All right, and then at this point here, either factor it or quadratic formula it. That's a verb now. Quadratic formula it. English teachers would hate me, wouldn't they? Okay, can you guys see how to factor this though? This one's pretty easy to factor. Factors are... Well, the factors are minus 8 and minus 2. So if the factors are minus 8 and minus 2, then the roots, or in this case, like our intercept values, will be at 8 and 2. Sweet. But we should always double check something. There is the possibility of extraneous solutions. And I came around and talked with all of you about how there could be extraneouses with the square roots. It is possible that when you were doing your graph and you had, like, say, your graph that, say, went whoosh, whoosh, and, like, something like that here. I'm not drawing this very nicely, but it's possible that somehow it was going to cross on the location of the asymptote. That could happen. So you should always double check to make sure that these answers right here are not going to be the numbers that you have problems with. See how like x minus 3, the one value you couldn't have would be 3. Just do a quick double check. You don't even need to check all of your work. Just double check to make sure that your non-permissible value doesn't somehow end up being the cause of the problem. Actually, I think I know why this occurs. It's usually with the hole in the graph. You have a graph that's supposed to have a hole in it, and then that hole is where it's supposed to cross. And so like you think that it actually intersects, but it really wasn't supposed to intersect. Long story short, just do a quick double check. Sound good? Okay, let's increase in complexity then. So, let's do this one. Sorry, I'm jumping around here because I'm hoping that our investment last year is paid off. Let's try this one. Can I do this? Oh, look, there's an x plus 2 right here. I'll just times it over to the other side right there. Not the opportune moment, right? Okay. Opportune moment is when you have fraction equaling fraction. So you got to play some algebra first. What you may find useful on this one is why don't you subtract the x to the other side? Peter, can you grab that door if that's someone trying to get in? Oh, maybe not. Never mind. Someone just literally ran into the door. Those junior high kids don't even know how to walk in a straight line. Okay, can I call it 5 minus x on the other side? Is that something you guys can handle if I change the order there? My personal opinion is I hate starting with a negative number. I don't know why, it's a pet peeve of mine. So if you did minus x and plus 5, it's the same thing. Well, look, hey, now is a great time to cross multiply, right? Because all you got to do is swing that x plus 2 over to the other side, and you'll have to FOIL it, right?
Mr. Bonnet, can you please call 3500? Mr. Bonnet, please call 3500.
You got a 5x, you'll have a negative 2x, you'll have a negative x squared, and 10's your constant term. There, now she's back. You can grab the door now. Am I losing anybody here? You guys can all follow this. Honestly, at this point here, we're past the hard part. Like, the hard part is dealing with the fractions. At this point here, it's just the algebra of quadratics. So why don't I bring x squared to the side over here, minus 3x over there. Okay. Do you want to go ahead? Okay. Yeah, go for it. Okay. Minus 4 equals 0. You guys get the same thing as me here? Maybe you're ahead of me. I think we need an x minus 4, an x plus 1. So x equals minus 1 and 4. Sound good? Quick double check. What's the one value we couldn't have ever used? Negative 2. Now we're good. Sweet. Not going too fast here? Okay, let's find the hardest one then. Sure, this one. The last one must be the hardest one, right? Must be. Okay, sometimes you might come across a scenario then where you have multiple fractions, and you may want to say, hey, look, I can cross multiply because, look, this 2x plus 5, I'll just bring it up over here. Ta-da, problem solved. Problem here being, though, we didn't actually have a scenario where you had fraction equaling fraction because of the stupid plus 2x right here. So this is more similar to the one I gave you in your skills journal. You need common denominators. So you may want to just ignore the right-hand side for a little while and just like leave that 8x plus 15 and the 4x plus 10. Just kind of leave it sitting way over here on the right-hand side. We'll get to you later. Because we need to common denominator the left-hand side. Again, I'm just making up verbs. We're going to common denominator this side. Well, this 2x plus 5 has a common denominator. Well, no, it just has a denominator of 2x plus 5, right? So why don't I times this guy over here by 2x plus 5 on the top, and by, oh, come on, board. Only have to last for like 10 minutes today. There we go. And times by 2x plus 5 right there. Is that step something you guys are comfortable with? Basically times it by the denominator. Okay, well, now I can write them all over a single common denominator of 2x plus 5. I'm going to FOIL out the top up here a little bit. So it's going to give me x plus 4x squared plus 10x. Maybe I'll pause for a second because I'm going a little faster now. Like these two right here? You could put them together right away. I've said this to you guys before. Sometimes there's right answers and then there's not helpful answers. I don't want to say wrong because you could write it as x plus 10x. That's not wrong. But 11x might be more helpful in this scenario, but it might not. It really depends on like where things go. You understand what I'm saying here? So like I think you need to be prepared for the fact that if you put them together, these two numbers here, and like later it becomes useful to separate them, then then separate them. But I'd agree with you though. Like I don't see any reason why not to at this point. Right? So if you wanted to just quickly throw them together as an 11x, I mean, it's not wrong. It may end up being something we fix later. So what would that make it 11x? Wait, well now we're at a spot where we've got fraction equals fraction, so now we can cross multiply. Quick reminder, here's what cross multiplying really means that you're doing. Don't write this out, but just, it doesn't hurt to remember what a cross multiply is. What you're really doing is you're timesing this side of the equation by 2x plus 5, and you're also timesing this side of the equation by 2x plus 5. Now, it looks like you're bringing this 2x plus 5 up to the other side, but really what you did is you added one to both sides, and then the one that's over here canceled that one. Does that make sense? That's actually what you're doing. It's just we don't talk about that every single time because it gets kind of redundant to say that every single time through, right? So, and then we could also bring this other one up over here. So here's what you're going to have. You're going to have 4x squared plus 11x. And it's going to need to FOIL into the 4x plus 10. And then on the other side, you're still going to have your 8x plus 15. And it's going to have to FOIL into your 2x plus 5. Everybody's still on the same page at this point? Okay, time to FOIL. I said this earlier in the semester. It's not harder, it's just more work. It's just going to be a lot here. All right, 60 next to the 3 plus 44x squared plus 40x squared plus, oh goodness, is that 110x? Yay. Okay, and then on the other side, we've got 16x squared. We're going to have 30x and 40x and 75? 5 times 15? Yeah, 75. Anybody getting a sense of where this is going? How many answers might we have? We might actually have 3. Why are we going to have 3 possibly answers? Yeah, it looks like we have a cubic here. Good news though. Taught you how to solve cubics earlier this year. Aren't you so glad I gave you that skill? Let's talk about why this might be a cubic real quick. Take a look at this example right here. Now, this graph right here is not one that I'd normally expect you to know. Okay, like that's maybe not a typical graph, but why don't we graph them real quick in our calculator just to get a sense of what the picture would look like. just as a bit brief aside here, if I were to graph, where is it here? Clear you out, x over bracket 2x plus 5, and then after all that add 2x. I mean, that's not a standardized kind of graph we'd look at, right? But if we were to take a look at what that graph looks like, okay, that's a funky shape. There's an asymptote. It actually kind of makes sense where the asymptote is, because really there's a number you can't have here, right? So I mean, if I were to overlay this one graph, that looks like it has the rough shape of up here and then like that. Okay. But let's say I want to talk about the other graph. You know how the other graph, maybe it has like one of those traditional kind of swoop kind of looks to it. Can you kind of see how maybe it's possible that you could have 1, 2, 3? That's possible. So anyways, I digress. I'm getting a little off topic. Only problem is it sucks because we got to factor one of these guys. We're so fortunate to have a really nice, kind teacher giving you easy questions. All right, let's bring everything to one side. So the 3 will stay on this side. 40 and 44 gives you 84, and then you got to subtract 16 from 84. 66? 68? You guys have calculators. Okay, and then you got 110, but you're minusing 70, so that's 40x. And then you got a minus 75 at the end. Is everybody in agreement on our cubic? Okay, so we just got to look for numbers that fit with the 75. So let's give everybody 1, okay? You guys know what I'm talking about to do here, right? We're going to test 1. Let's not test 2. 2 doesn't go into 75. Let's test 3, not 4, and 5. Why don't we try that? So can you try plus 1? Can you try negative 1, plus 3, negative 3, plus 5, negative 5, plus... What else goes into 75? Yeah, I'm trying to think of what else. Yeah, I mean, it could be a 25. Okay, well, just use 60. You just sit there. Did you find one, actually? Okay, so we got that far. Just confirm that. Try the 3s and the 5s. I guess, yeah. I can't think of anything else that goes into 75 right now other than 1, 3, 5 must go. What's 5 times 5? 15. Okay, try plus or minus 15. Not negative 3? I'm hoping that I didn't miswrite this question and forgot about it all this time. 3 doesn't work. I'm going to grab my own personal calculator. I just want to test something. What was the original? I'm going to graph the original now. X divided by bracket 2x plus 5. And then plus 2x. And then the other one is bracket 8x plus 15 divided by 4x plus 10. Oh, no, there's an answer. Okay. Okay. Actually, this is a good learning moment. So it looks like solving using quadratics or using this cubic thing is not helping us here. One thing that we haven't considered here is that this is only going to work if we're going to get like whole numbers though, right? This is only going to work if we have like 1s or 2s or 3s or something like that. And I actually just real quick graphed it and intersected, and I managed to find an answer. So there must be a solution, but it means we need to consider alternate ideas. Okay, so alternate idea number 1. Literally just go back to your original here, and it kind of sucks that we wasted all this time, but we could make this equal to y1, this equal to y2, and we could just literally find where they cross. That's what I did. It took me 4 seconds. Right. So I mean, if this was your question on the diploma, don't get pigeonholed into thinking, oh, I have to do it algebraically, because it might just be faster just to plot these two things here. Right. Just so you have a quick idea of what they look like. One of them looked like this and this, and then the other one looked like, let's see if I can do this, looked like this and like this, and they definitely cross right about there. Okay, so that's one option. There is one more thing I should point out, and I knew this all along. I wanted to see that we can get by without doing it. This 2x plus 5 right here, and this 4x plus 10, one is a double of the other one. Anybody notice that? I did a long time ago. I actually chose to just run with the flow. So I want to repick things up on this step right here. So if you could, let's just repick things up on this step here. I'm taking a lot longer today than I thought I was going to. I'm sorry. Rewrite 4x squared plus 11x bracket 4x plus 10. And then you've got your 8x plus 15 and your 2x plus 5. Here's another idea we could play. That 4x plus 10 right there, you could write it as 2 bracket 2x plus 5. You guys see what I'm talking about here? That 4x plus 10 can factor into a 2 and a 2x plus 5. So I'm just going to change the one out for the other. Well, now you have a 2x plus 5 on both sides. You could cancel it, yeah. You could cancel it. Which would leave you with 4x squared plus 11x, which still has to get times by 2. And then you have the 8x plus 15 on the other side. Okay, so the 4x plus 10, I factored into a 2 and a 2x plus 5. 2x plus 5 cancels, but the 2 is still left over. I'm going to stop here. I don't actually want to solve it. I just want to talk about how you'd solve it if you had to. At this point here, you'd distribute the 2 in, you'd bring everything to one side, it would give you a quadratic, only this quadratic apparently can't be factored, which makes sense because you know how when we had it as a cubic, we weren't able to factor it either? Right? But it does mean that there could still be answers. Those answers just might be based on the quadratic formula. Right? So, I mean, I've got an answer here of 0.75 and 1.6153846. But I mean, it does look like when I graphed it, I found that they could cross. But as I look at it, 0.75, I never would have got that from factoring. Right? That wouldn't have shown up from you get that from a quadratic formula or something. So, anyways, I've taken up enough of your time, I think, today. Do you guys get the base idea, though, of how to work with rationals? Obtain common denominators, put them together, cross multiply. You may get extraneouses. You may end up getting cubics. It's possible you can get that high. You may have to use the quadratic formula, but I think you guys know where to go from here. So, okay, last passing stop. Then I'm going to stop talking for the day. Let's take the last half hour today to work on this, and then I'll print off the first quiz for tomorrow, and I'll let you guys choose when you want to write it. So, like, if you want to maybe work on the assignment for the first half of tomorrow, and then start it Thursday, finish Friday, I'd be okay with that. I don't know when else would really work for you guys. Actually, most of you guys have third block off on Fridays, right? Does anybody have a class third block? You do. You're doing the calculus stuff. If you wanted to, we could have all of tomorrow as work time, and then you guys could just use third block into fourth block on Friday if that works better for you for writing a quiz. Okay. So, anyways, how about this though? I'll leave it up to you guys. You guys choose when to write it. I don't care when, but sometime before the weekend, try quiz 1, and let's see how it goes. Sound good? Okay. And break. Oh, it's only 24 minutes. That's not bad.